Hello everyone. So in this video we are going to discuss the high-level system design of Dropbox. Dropbox is a cloud-based file storage service that allows users to store or share files across different devices. So like our previous video, we'll divide this video into four parts. First one is requirements, where we'll gather all the information regarding what the user should be able to perform in the application and how the application should behave. The next step is entity defining and API design. Here we'll define different table that we are going to store in the database, and in the API design we'll define different HTTP requests that are need to perform our operations. The next step is high level design. This is where we'll try to draw different diagrams and understand the flow of different requests in our application. The next section is the deep dive. In this section, we'll try to satisfy all the different non-functional requirements that we have defined in our first step. So without any further ado, let's get started. So I'll resize this a bit and keep it here for our reference. So the first step is requirement gathering. First, we'll list out all the functional requirement. These are all the requirements that user should be able to perform with our application. So as it's a file sharing application, the user should be able to upload a file from any device. That means from the mobile device or web device. Next, user should be able to download the same file. The next one, user should be able to share the file with other users. And the last one is the auto sync of files across different devices. So here, these are four functional requirement that we are going to take in our high level design. We'll try to keep the requirements as minimum as possible so that within 40-45 minutes of time we can design the system and satisfy every requirement. Next comes the non-functional requirement. Here, as we have mentioned earlier in our last video, the first thing that we should cover in non-functional requirement is the availability or the consistency based on the CAP theorem. So here the system should be available rather than consistent. What it means? Consistency means whatever there in the database, either it should show the exact information to the user or it should not show anything. So this is applicable in case of finance system like banking or share trading, that we need the actual figures that is there in the database. But if let's say in our application Dropbox, if we share a file and that file is not visible to me, or if I shared this with my friend and that is not available to him, for a couple of minutes, then it's not an end of the world. Moving on to the next requirement, application should support uploading of large files. Let's say we can quantify it as 50 GB or something. The next non-functional requirement is low latency in uploading, downloading, and sharing, right? So this completes our requirement gathering phase. Now next we'll define the entities. So here we won't be having much of entities. We will have the actual file, the bytes and file content. Next we'll have the file metadata, which contains the name of the file, the format, and what is the size of the file, these information. So next one will be file metadata. Last one will be, of course, the user who is uploading or downloading these file. In this step, we are not going to define different attributes. This we will define while doing the design. It's better to do it on the later stage. Now next comes the API contract. So try to correlate this with the functional requirement. The first one is user should be able to upload a file. So this will be a post request, let's say API files, then it will contain in the request body, it will contain the actual file, then file metadata. Next one is should be able to download the file. So it will be a get request, same endpoint slash files. You will provide a file ID. What it will return? It will return the file and its metadata. Next, we are going to define the user should be able to share the file with other users. So again, it will be a post request. It will be a post request, let's say API files, file ID, specific file which we intend to share, then share. It will have a payload, the list of users with whom we are trying to share this file, right? And last but not the least, if I download or upload anything to my account, then all the documents should be synced across all my devices. So it will be a GET request, same endpoint, API, files, and it will contain some parameters like we will try to look for changes, be it in our local device or in the cloud storage, whichever has a difference of files, we will try to upload or download those files. We will provide a timestamp, and in return, this will sync our local and remote cloud storage with each other, right? So with this, we have completed our second step of API design and entity defining. Now we'll move on to the high level design. So let me do a little bit of resizing here. So in our high level design, we'll try to satisfy all the requirements that we have mentioned in functional requirement. So the first requirement is user should be able to upload a file. So user will be uploading the file from a mobile device or from the browser to the cloud. Then this request will go through API gateway. This API gateway will perform some sort of authentication. Then if require any rate limit, we don't want to spam our application with repeated request, then routing of request to the particular service or the targeted service. Next we need a service. We can name it as a file service. Then we need some sort of database to store the information. Database. So the request will follow like this. Client will make a request, that a post request with the file information and file metadata. This will be processed by the API gateway and it will be directed to file service. File service do the process and it will store the information inside the database, right? So here we can define the entities like the file metadata. It will contain a ID, then name, then size, then MIME type. It is basically what type of file, be is a MP4 file, a PDF file, a audio file, what kind of file it is, then the actual file. So this satisfies our first endpoint, that is upload. So client will upload the file from here. It will go processed by API gateway, then it will be sent to file server and it will upload the file to the database. Now, the main requirement here for a system like Dropbox is to allow user to upload file. When it comes to storing a file, we need to consider two things: the actual file content, that is the raw bytes, and the file metadata. In this case, we are considering a NoSQL database, let's say like DynamoDB. So DynamoDB is a fully managed NoSQL database that is hosted by AWS. Because our metadata is loosely structured and we are not going to have many tables, which requires complex joins and it requires frequent get request or post request. So that's why it's better to go with a NoSQL database, DynamoDB. Now, as you can see, we are storing the actual file in the database, which is not a good idea. These are document database which are not very efficient for storing the raw bytes. So to do that, we can take help of some blob storage. So there are lots of different kinds of blob storage that are available. We'll take, in our case, S3. This is provided by Amazon. Likewise, Google also provide this kind of blob storage, that is Google Cloud Services, GCS. So in this case, what the file service will do, after receiving the file, it will send the file, actual file, the raw bytes to the S3, and in return it will get some S3 URL. Now this URL will be updated in the file location like S3 and file. So this completes our file upload process. So there is some limitation to what we can send over the normal HTTP request. So in a payload, let's say we can send less than some 5 to 10 MBs of information. So if we are uploading anything greater than that, then this is not possible to upload it via a post request. So in that case, what we can do is, let's say the client makes a post request to upload the information. This request will be processed by file service. It will go to the S3 database and it will get some pre-signed URL. Then it will store the file metadata into the DynamoDB, and in response it will send the pre-signed URL to the client. Now using that pre-signed URL, client will upload the file directly to S3 storage. This pre-signed URL, it is the very short-lived in URL that contains user information. So within that window of time, the client needs to upload everything into the S3 database, right? So this solves our issue of uploading large file into the database. Now this is okay for we have completed our upload process. The next endpoint is to download the file. So from here, client will send the GET request for that ID. File server will process it, get the metadata from the DynamoDB. Using that URL, fetch the actual file from the S3 and responds it back to the client. So as we have discussed earlier, if the size of the file is more than, let's say, 5 to 10 MB, it is not possible to transfer it via HTTP request. So in this case, we'll follow the similar approach that we followed during upload. So when the client makes a request, the file server will process, get the information from the metadata, and it will send the file link directly to the client. So the client can directly download that file from the S3, right? So let's say while getting the file, the client and this S3 database, they are geographically very far, right? So in this case, if the size of the file is very large, it will take a huge amount of time to download the file. In this case, we can take help of a content delivery network. After uploading a file to S3, we'll sync the information to the CDN, and using the same URL that will be shared by file service, user can download directly from the CDN, making the download experience very fast. So now we are done with the second endpoint also. Next we have the third endpoint, that is file sharing. So the simple solution is to create a field inside here, let's say share, and store the list of user, and we can create a data like uploader. So now whenever any of these user try to get the files that are being shared by them, so DynamoDB will go through all the file metadata, try to collect that particular user from the share field, and those file will be shared with the user. So as we can see, this is not a very efficient method, because after some time there will be lots of file, and just to serve one user with the shared file, it is not possible to go through every file and get the user information, then share the file. It will take a lot of time, and this is not a very efficient process. We can create another table called shared file. This will contain two fields, user ID and the file ID. Just only two things. Now we can provide some indexing to this user ID, so that we can figure out all the files that are shared with that user, and we can share the information with the user very quickly. So in this case, we don't need to have these fields in the metadata file. Now going back to the next endpoint, that is change. Let's say I upload anything in my local device, and that is not available in the cloud. So here we can say there are two scenarios: thing that is available in my local but that is not available in the remote storage, or it is available in the remote storage but currently the device that I am using, it doesn't have it. So we need some sort of trigger from both the local device and from the remote, so that if any discrepancy is there between the content that is stored in the local or in the cloud, then they will sync and the issue will be resolved. In the local device, we can monitor for OS specific system event like file system watcher or FS event. When it detects the changes, it will queue the modified file and upload directly to the cloud, right? So this solves our first scenario, local to, if the file is there in local and not in remote. Next comes the remote to local. So when user logs into the application and hits a refresh, then user should be able to see if any file is not there in the local and that is present in the remote. Let's see. Okay. So there are two ways that we can do. We can create a WebSocket connection, keep alive, and if there is any changes on the cloud storage, then those change events will be shared with the client and client will download that file, right? So here we have one issue. The WebSocket is that needs to be maintained for a longer period of time. What happens if sometimes the WebSocket connection get dropped, then for that duration we won't be able to sync these both devices. So to do that, to deal with this thing, we can come up with a long polling. So periodically client device will send request to the cloud storage, and based on the last time that it was synced, it will try to see if any other file is there. If it is there, then it will try to download that one. This way, now we have covered all the four functional requirements here. Now let's come to the non-functional requirement. Now let's discuss the non-functional requirement. Here the system should be available, highly available. So that somewhat we have already achieved. The client can directly upload the files to the S3, and via the CDN, user client can download the file, a faster way from the CDN. Now when it comes to support the large file upload, so we have till now we have discussed, let's say the file size is of 10 GB or something. So in this case it is fine, but if the file size grows beyond that, uploading a single file using a single pre-signed URL, if anything happens to the network, if the network connection drop or the system dies down, then the upload fail and user need to start uploading again. That is a very bad user experience. So in this case, we should be able to upload large file. Also, we should support resumable uploads. So to do that, we can come up with a better approach to implement the chunking. So when a client sends a post request that this is the file I want to upload, so the file service will send a request to S3 and it will get a bunch of pre-signed URL, right? So we will not upload the file entirely in a single go. What we'll do, we'll chunk that large file into smaller size and will upload each chunk to each pre-signed URL. So user will receive the list of pre-signed URLs. Then via using this URL, user will directly upload these things to S3. Now we need to change the, in this case, file will contain a list. So the ID will be chunk1, status will be, let's say, uploaded. This will be for the first chunk. Then the next chunk is ID, chunk2, status is, let's say, uploading, like this one. It will contain different all the chunks information, and once these chunks are uploaded to S3, then this information will get updated. So how do we update this information? We can do one thing. From the client, after successfully uploading the file to S3, client will send a request that this particular ID of chunk is uploaded, and we can update the database. But sending the information, receiving the information from the client, we cannot trust that information, right? So we need to verify that information directly with the S3. So in this case, we can take help of E tags. So this is a concept that each chunk gets an E tag upon successful upload. Client will upload the chunk to S3 and it will get an E tag. Then it will send it to the file server for this particular metadata. It will be a patch request, and file server will send a request to S3 to verify whether this has been updated, uploaded or not. After that, it will modify the file metadata. So this way, it's a kind of trust but verify scenario that we are trusting the thing that is being sent by the client, but again we are verifying it with the S3 database. So here, to follow what we have implemented, let's say client post a request to upload a very large file. That file goes to the file server, sends a request to S3, get a bunch of pre-signed URL, and now client does the chunking of that file and start uploading information to S3. In response to that, client receives a E tag, sends a patch request, file server retrieves that E tag, verify that with S3 and update it in the Dynamo database. Let's say midway while in the process of uploading, the network got disconnected. When the network reconnects, we can get the information from the file server that from which chunk we need to start uploading again, and the client will start uploading again. So this is how the resumable upload works. And now the last one for the low latency that we have already addressed, like the upload time we can minimize by using chunks, the download time we can minimize using CDN, and sharing time we can minimize by using this share file table. The share file table will make the searching of other files which are shared with the user a much faster. This basically concludes our all the functional and non-functional requirement, and we have completed the system design of the Dropbox. I hope you like the video. Stay tuned for more videos like this. Thanks everyone for watching.